All right, so let's look at the last couple problems for 3-3. You're going to determine whether lines are parallel. So in this particular problem, it says you're given that angle 1 is congruent to angle 2. So the first thing I would do, if it's not in your picture, I would mark it up in your picture. Do those angles have a relationship? They're both what? Yeah, they're on the outside, so they are alternate exterior angles. And it says you can use the converse of the alternate exterior angles theorem to prove that lines R and S are parallel. What is another way to explain why R is parallel to X and justify your answer? So let's go through and justify our steps. So where do we get angle 1 is congruent to angle 2? Well, you know that was given. Then we can't go directly to the fact that, if alternate exterior angles are congruent on two lines cut by transversal and lines are parallel, because that's what we're trying to prove. So we're getting our way to it. So angle 2 is congruent to angle 3. How do we know that? So you're going to say not just vertical angles, but vertical angles are congruent. And then look, from here to here to here. 1 is equal to 2. 2 is equal to 3. 1 is equal to 3. What is that? It is the transitive property, isn't it? What you end up with here is what you start with here. And so that we take away what's doubled and write just what's left over. That's your law of syllogism also, isn't it? So the transitive property is identical to law of syllogism. That's what law of syllogism uses. And so that's what we use here. Transitive. Technically you could put law of syllogism if you wanted to. But I would always put transitive property of equality. And so we already determined angles 1 and angle 3. Well, we didn't determine that. What's angle 1 and angle 3 to each other? They are corresponding. So, because that's what we ended up with, angle 1 and angle 3 are congruent, what postulate or theorem can we now also use to explain why lines R and S are parallel? So if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So again, I don't memorize what the theorem's name is. You just need to know what it says, and you need to be able to use it forwards and backwards. Because I started with congruent angles, my conclusion was I had parallel lines. So my if part has the congruent angles in it, my then part has the parallel lines. If I was told that the lines were parallel to begin with, I would have written this in reverse. I would have said, if two parallel lines are cut by a transversal, then corresponding. All right, so flip this. The marked angles are, and then you go ahead and circle what you think is appropriate, and then circle the appropriate theorem, and then I want you to use that theorem to solve it. So you go ahead and do 19 through 21 on your own. Once you get an answer, I want you to compare that with somebody around you. All of the answers, 19, 20, and 21. So talk. It's so quiet on a Monday morning. Everybody chat with somebody. Maya talked to Kate. She's all by herself over there. Fashion statements, Nordstrom's rack has quite the selection of bow ties. Was that two ties? Okay, ready? All right, so let's look at question 19. The marked angles are on what side? Same side of the transversal. And then 20, by the corresponding angles theorem, did they have to tell you that? Nope, you should have known that. If line C is parallel to line D, then corresponding angles are congruent, and so then that should have helped you solve for W. So you should have set the angles equal to each other. Your only option is to set them equal to each other or add them together to set them equal to 180 on these types of problems. And so because they are congruent, set them equal, I must see the minimum of this work. You can't go directly to 3W equals 57. You can't go directly to W equals 19 without any work. I have to see where did you start and how did you end. Now, if you're not going to show adding 2 to both sides and divided by 3, that's fine at this point. We're not going to go assuming. If you want to still show that, that's fine too. I don't care. Either way. So questions on that? Watch and make sure that they didn't ask for W versus ask for the angle measures, although what should be the measure of 3W minus 2? What should the measure of this angle come out to be? 55. And so that's a way to check it. You can put 19 in, multiply it by 3, and subtract 2, and you should get 55. So when you take your quiz, you ought to know whether you have a correct answer or not, based upon the work. And also, visually, do a visual check. Are these angles both acute, or is one acute and one obtuse? They're both acute. If they're both acute or both obtuse, then you know they have to be equal on this particular type of diagram. If one's acute and one's obtuse, they have to be supplementary. So use the visual cues as well as your knowledge of those angle relationships. So I'll do that. All right, so then you're going to do 22 and 23 on your own, and then we'll be done. Go ahead and explain your results to people around you, especially for number 23. All right, so I actually wrote a long explanation to number 23. You might have written a shorter one, it just depends. I want to make sure I got my point across. So for 22, those are the three sides. It says circle the segments that are sides of angle D and C. I don't know if they meant the lines that were crossed by the transversal or the sides of the angles themselves. It's kind of a fuzzy question. So these are the three sides of the angles themselves. Isn't AD, and we'll just put a box around them, isn't DA, which is AD, and BC, right here, aren't they the lines that are cut by the transversal BC, which the two angles are on? Would you not agree with that? So the fact that the student said that AB is parallel to DC, the angles are not on the transversal that cuts through those two lines. One angle is on that transversal, the other angle is on the other transversal. But those two angles that you trace with your finger are on the transversal BC, which cuts through these two lines. So those are the two lines that would be parallel. And here's why. And here's what I said. Since the 83 and the 97 add up to 180 degrees, then AD, segment AD is parallel to segment BC because angles D and C are on the transversal BC, which intersects AD and BC. So then I went and I stated the theorem. So if two lines are cut by a transversal and the same side interior angles are supplementary because they are same side interior angles and they are supplementary, then the lines are parallel. But you have to choose the correct lines that are parallel. So always trace your angles and you'll see that transversal and you'll also see the lines that you're cutting through. Brody, your head's on the desk. Because your explanation probably wasn't the same as mine. I'm guessing you should probably fix it. Yeah, not quite the same. So that's all I have for today. So tonight's assignment should be, more of an emphasis of what you did on Wednesday. And so you're going to work on that today. I'm also going to give you back your tests, and we're going to look at that as well. And I owe some of you double candy bars.